Today's lesson, Unit 7, Day 1, Equidistant Locus Theorems. First question, what is a locus? A locus is Latin for place. So it means a location. We are going to be doing today, sketching different locations of where things could be, almost like a treasure hunt. There are 6 total theorems. We're going to talk about 3 of them in this lesson. These 3 are called the equidistant locus theorems. The first one is the set of points equidistant from 2 given points. So that word given means you'll be starting with those 2 points. And if I said you have to travel so that you're always equidistant, always the same distance away from both, you sketch in that path, which just so happens to be that path, sort of common sense. Now the math tie-in to this is that that path is the perpendicular bisector. There's my symbol for perpendicular. Now I don't want you to sketch this in your notes, but visually, here is the segment that we would be bisecting. So those 2 pieces would be equal, and this would be a right angle. But remember, we start with those 2 points. So that's the first one. Like I said, sort of common sense. The next one, I want to sketch the set of points equidistant from 2 intersecting lines. So this would be like 2 sidewalks maybe that cross, or 2 roads that cross. And if I say, well, you have to walk so you're always equidistant from the 2 intersecting lines, there's actually 2 paths you could take. There's one path, and here's the other path. So you would sketch those in. The math term for those would be the angle bisectors. And the third theorem, there's only 3 we're going to talk about in this lesson, would be the set of points equidistant from 2 parallel lines. So in this case, I would ask you to walk or travel so you're always the same distance away from both parallel lines. It would be this path right here. And the way you would describe this would be a third parallel line exactly between the given lines. Now let's take a look at some examples. The first one says, sketch and describe the locus of points equidistant from 2 parallel lines that are 10 units apart. So not only do you have to sketch and describe, but you have to also draw the given information. The given information in this case will be the 2 parallel lines 10 units apart. That's how you start. Generally what we like to do is make our given information solid lines, and then the locus is dashed. So I've got 2 parallel lines and they are 10 units apart. I kind of use a brace to represent them like that. That's 10. So from the theorems on the previous page, when I give you 2 lines and I want something that's equidistant from those, you sketch a third parallel line right down the middle. So it would look like this. To complete the sketch, you have to indicate to me you know how far that line is from the other 2. So if the 2 lines are 10 units apart, simple math, that line is 5 units apart from each. And then how would you describe it? A third parallel line, 5 units from the given lines. Our next example, there are 2 floats on a lake. Determine the path a girl must swim so that she is always equidistant from both floats. Basically here we need to figure out, okay, 2 floats on a lake, what would that represent geometrically? 2 dots. So you do something like put a point there, there's F1, put a point here, there's F2, float 1, float 2. And then the path the girl must swim, so that she's always equidistant, remember, is a perpendicular bisector. So you sketch a path that would be perpendicular to the path between F1 and F2, and exactly halfway between. So now how do we describe it? You would say something like the perpendicular bisector. Now technically it would be the perpendicular bisector of segment F1, F2, but I'm fine if you just say perpendicular bisector. Example 3, a boy walks through an open field that is bounded on two sides by straight intersecting roads. He walks so that he is always equidistant from the two intersecting roads. Determine his path. So two intersecting roads basically represents two intersecting lines. And I don't really care how you draw the two intersecting lines. You can kind of do it like this. You can do an X, however you want. But it's bounded on two sides, so I'm envisioning that this area right here is the field. And you want to walk so that you're equidistant from those two roads. It'll look kind of like this. And again, your diagram doesn't have to look exactly like this if you kind of drew an X and drew a path between them. Determine his path. This, remember, is called the angle bisector. It's the angle bisector of the angle formed by the two roads. Example 4, an elementary school is situated at the intersection of two busy roads. The PTA wants to build a new playground in front of the school that is the same distance from each of the two roads. The PTA is a scale drawing similar to the diagram. How can the PTA determine the possible locations? So again, what we want to do here is try and envision one of those three scenarios on the first page of the notes. So we have intersecting roads, and we want to be equidistant from the intersecting roads, just like the one we did up above. Basically, you want to draw this path here. If you want to get really detailed, you can mark those two angles. You can place the playground anywhere on that path because that path is equidistant from the two roads, which is an angle bisector. The last thing we're going to do is review our equations of lines, because we're just not going to do this freestyle like we did on the first couple pages, but we'll also do this on a coordinate plane. So, review of horizontal and vertical lines. General form of the equation of a horizontal line is y equals some number. That slope, if you remember, is 0. General form of the equation of a vertical line, then, would be x equals some number, and that slope is undefined. We are only going to deal with vertical and horizontal lines in this unit, so you don't have to worry about your y equals mx plus b. But I want to make sure we can graph these before tackling some locus questions. So very quickly, I want to graph the following lines. X equals 3. Now, I'm not going to write this out on every problem, but just a quick review of how I taught it a couple units ago. X equals 3, remember, crosses the x-axis at 3. So here's my x-axis, crosses at 3. That right there is the line x equals 3. So when you hear x equals something, remember it crosses the x-axis at that number. That's how you remember that it's vertical. So then y equals -1, I remember, crosses the y-axis at -1. So where's my y-axis? Here's my y-axis, crosses that at -1. This is the line y equals -1. From here on out, I'm not going to write down the crosses the x or crosses the y-axis. Letter C, x equals -4. That means it's going to cross the x-axis at -4. You just go over to -4, 1, 2, 3, 4, draw a vertical line. There's the line x equals -4. And y equals 2 crosses the y-axis at 2, so that's horizontal. Y equals 2. Now let's apply this to two quick examples involving locus. Example 6 says, graph and state the equation or equations of the locus of points equidistant from the lines y equals 6 and y equals 2. So the first thing we need to do here is graph those two lines. Y equals 6, y equals 2 are two lines. They cross the y-axis at 6 and at 2. So I'll do this one first. There's the line y equals 2. Let's go up 6, 3, 4, 5, 6. There's the line y equals 6. You want to do those solid because those are given lines. The locus we like to do dash. So I want the locus of points equidistant from those two. Well, that's simply going to be a line that's exactly in between them and parallel. You can count the blocks, the spaces between. There's 4 spaces between, so this would be exactly between 2 spaces. Draw that in as dashed. And write the equation. That's y equals 4. And that is the only equation we would need. You don't necessarily have to write the equation of the other two lines. I'm just kind of doing it for review. But you want to make sure you write y equals 4 as your final answer. And then the last one. Graph and state the equation or equations of the locus of points equidistant from the points A, negative 5, 2, and B, 3, 2. So first thing we would do is plot our given information. 2 points. A is negative 5, 1, 2, 3, 4, 5, 2. So there's point A. Point B is 3, 2. 1, 2, 3, up 2, there's B. So the first thing I would do here, I wouldn't write this down, I'm doing it for the sake of notes, is I would count the number of blocks between those 2 points. 1, 2, 3, 4, 5, 6, 7, 8. And then if you want to be equidistant, you have to be half of 8 or 4. So then you count 4 one way and sketch that in. So that is the path that's equidistant from both of those points. The equation is a line, x equals negative 1. And that concludes lesson 7.1.